Okay, today we're going to measure this bar. This is one that we machined on the metalworking planer. I'm going to use my 1:2 micrometer here. Alright, we'll see how parallel it is. Looks pretty good actually, but we'll soon find out. Just make sure you clean the anvils. What have we got here? 1.085, 1.085, 1.084, and we got 1.087. Some little discrepancies there. And let's just measure this side as well. .085, 1.085, just about 85. 1.087. Okay. It's not bad really for the size of it here. I'm quite happy with that. Like I said to you before, yeah, we still got to do some work on the bed and the table, scraping and things of this nature, but that's not bad at all for the size of component. That's not bad. Right, let me put this away. I'm going to get a 2 to 3 micrometer out and we'll measure it that way. Right, where's that? Do this way. Okay. Yeah. 2 to 3. A lot of people like to check these on the gauge every time they use them, but if you spend the time doing that all your life, you'd never get anything done. You've got to trust your equipment. Know when to check it, when not to check it. Alright, let's have a look. Alright, what we got here then? We've got 2.691. 2.691. 2.692. Just feeling very dirty. Debris on there. She was clean. The anvils too. 2.691. That's not far out, is it at all? It's pretty good, that is. 2.692. 2.692. 2.691. So that's pretty good. Actually, it tells me that I don't think I need to worry too much about the bed. I mean, that discrepancy in the other direction, that could have been a number of things that may not have been quite down flat. There may have been some distortion when we machined the faces. And then when we clamped them down onto the bed, that distortion maybe caused the irregularities. What you would normally do if you try and machine a planer face like this, no matter it's on a milling machine or a planer, shaper or whatever, is you'll probably take a skim pass off, get underneath that hard scale, the black scale on the metal, turn it over, you'd cut it off again on that side, you'd keep turning it over until it was parallel. But you've got to be careful how much material you've got, because every time you take a cut you're going down further, and you've got to consider it takes time and effort to do that. So you've got to determine whether you need to do it or not. If you're manufacturing stuff and you've got to get production out through the door, you're not going to be too keen on having to change your setup, turn it round, clamp it back down again, set it up again. It's going to take time and money, so you've got to make your decision as to whether it's worth doing or not. I'm quite happy with that. I think the planer's done a really good job. Let me just turn it in a little bit more. So now, put that in as well. Now what we're going to do, I'm really happy with that. So now what we're going to do is, put this away, now we're going to have a look at how we're going to machine the ends. In the last video, I did mention to you about the 3 methods that I would consider we could use to do this. That's machining the ends square to all the faces. Hello and welcome back to the shop. It's now a couple of days since we measured the bar that we machined on the planer here, and you can see I've cleaned it down ready now. This is ready for the next job, whatever that may be. And it may be we're going to do one of the bigger bars there, because I want to make some tooling for my lathe. So I need a piece cutting off the end of one of them bars, probably about 6 inches long. But what we will do is, rather than just cut the piece off and then machine it 6 inches long, we'll machine the whole thing and then we'll cut the piece off. But anyway, today we're going to talk about machining the end of the bar that we machined on the planer machine here. I'm just going to get the bar and show you. Right, this is the bar that we machined. And we did all 4 sides. And as we saw when we measured it, it's pretty parallel. It's also really square, and I'm pleased with that. I think this old machine here has done a really good job. Really good job. And what was really interesting for me was the work holding systems that we used. They worked really well, and that's how they used to do it in the old days. So if you think about it, if you have a big flat surface that you need to machine, you can't put clamps down or whatever, but using wedges and things is an option for you. But you need to be very careful. You don't want something to come flying off the table, especially on a milling machine. Anyway, what we're going to do is we're going to square the ends up. And in doing so, square the ends up, machine the ends, or whatever we're going to do with them, is going to finish this test piece off. And remember, this test piece was to prove that the planer is capable of doing a good job, which I'm quite happy that it's done. It's bits done now. It can't machine the ends here for practical reasons. It's impossible for it to do it. So what we're going to do is we're going to put it either on the shaping machine or the milling machine, or of course we could use files, hacksaw, things of this nature. But what we have, let me just show you, I don't know if you can see this, we've got the flame cut end here, so that's going to be quite hard. We've got underneath the skin no problem whatsoever with the planer on the sides. We've got to do it on the end here. Now what I'm thinking of is, if we did that on the milling machine, I really want to use a carbide cutter on that rather than high-speed steel. I prefer to use carbide cutter. If you do it on the shaper, we could use high-speed steel. It's not a problem. But why machine that? Why not just cut it straight off and then machine it where you're down to good material? So what we can do is we can use a nice little machine. Let me put this down here. Let me just show you. Alright, what I'm thinking of doing is just cutting the ends off with this, my little Power Hacksaw. I made this from a kit of raw materials from Hemingway kits. I've done quite a few of their kits. I'm quite happy with what I've built so far. this was a really interesting little machine. I wanted a small power hacksaw. Could have a bandsaw. You know, like many people have a bandsaw, really useful machine tool. But I like the old style equipment, and I fancied to go at building something myself, so I built this from the kit of materials and drawings, and it works really well. It's slow, yes, I know that, but I'm in no hurry. If I was running production work or whatever, I'd probably have a bandsaw, just simply because it's much more efficient and effective, does things quicker, it's a lot easier to use perhaps. But this is a really nice little machine. It's got quite a few little interesting features on it. It's got automatic stop switch here, and it's got a little damper, so it slows it when the ram here is dropping down. It slows it down. It's got a stop as well, so you can just put your work up against the stop. So for a small bar, for example like this 3/8 bar, which incidentally is for the planer, it's for the forward and reverse mechanism. This material came about a week ago, so that's another job we'll be doing sometime in the future. But this is a really nice little machine. I always give it a good oiling before I use it, because it's got a total loss system, and we mentioned total loss systems before. So let me just put a bit of oil in this here. There you go. There we are. Yeah, it usually just rolls all over the place. That's why I have a towel at the back here to catch the oil. And then just put some main bearings as well. It's really effective, but like I said, it's slow. And there's many parts I've cut off on here. I mean, I can actually cut them faster on in the vise with my hand operated hacksaw. The power hacksaw just saves me so much messing around, and I like using it. It's a nice little machine. Like I said, it's really effective, and it will actually, believe it or not, it will cut through that bar. It will take some time, but it will cut through the bar. And you've got to be careful on this. So once it's a fractional horsepower motor here, and as part of the build, you don't use the fan on the back, and I don't like that. I prefer the fan for cooling, because one of the things I know about this, when it is working over long periods of time, it does get hot. So what I'll do is I'll let it run for so long, and I'll just shut it down. If it's a big piece of work, it'll go through an inch bar, no problem, 1.25 inches, 1.5 inches, no problem at all. But yeah, we can use this. We can cut the end off, cut that flame cut end off on both ends of the bar. That leaves good material then for a simple clean-up cut on the shaping machine, which is what we're going to do. So what I think we'll do now is we'll just set this up. Let's move this bar out of the way. I'll put it down by the planer with my spring steel and brass angle and other things here for me locomotive when I get around to doing it. Right, let's grab this bar. Just out of interest here, the blades are only 10 inches long. Very rare blade now. In the old days it was a common size. And the only ones that are available that I know of are 24 teeth, which is this one here, the Eclipse ones. 24 teeth, and this is the one that you get with the kit of materials to build this. But I wanted something with a more coarse teeth, number of teeth per inch. So what I did when I was at the model engineering exhibition last year, bought myself a pack of Eclipse 18 teeth per inch blades, 12-inch long. And then what I did is I cut them down to size and drilled a hole in there. You can drill these easy enough. They're bimetal, flexible bimetal, high-speed steel. So just the teeth itself are the hardened bit. The rest of it's quite flexible and soft. So you can drill through there. I mean, if this was solid high-speed steel, if you had a carbide drill, you'd probably be able to drill through that, no problem. But these are quite effective. I've only been running this probably for a couple of years now, It's been a lot of work. It cut all the angles for the table underneath the planer. So it's done a lot of work, the old blade had. And you get a lot of vibration when the blade starts to deteriorate. And I changed it, put a brand new blade in, and it was superb. It ran really well. But anyway, that's that right. I should put that back. The blade that we've got in now is still okay. Right, what we'll do is we're just going to cut the very end off to make sure we get rid of any hard scale. Use another little support. Make sure our jaws are clean. Right, now let's put the file in there. We'll do it this way around because it'll be easier, I think, for the machine. A bit further out. I'll just do this. And just move this a little bit. You want to cut off anything unnecessary. We're fortunate that there's no set length for our work here. This is our test piece. If this was an actual component, then obviously you want to make sure that your flame cut blank is big enough so you can crop the ends off but still have enough material there to clean it up. You don't want to have flame cuts which dead size, you'll be knackered then. Don't be afraid to add a little bit extra on. It's better to have too much than have too little. Alright, let's just have a look. Put your safety glasses on, keep people happy. Alright. Oh, I switched it on yet. There you go. Alright. You have to switch it on here. The design itself has a little switch on and off here. And then it was wired direct to the mains, but I didn't like that because if there's something happened, I can't get at that switch. I like to be able to get to that E-stop, the controls here, independent of that. So let's just see what it does. See? Nice and steady little machine. It'll take a long time to get through that. But if you're doing that by hand, you had a hacksaw, it'll take you quite a while as well. Now let's just see what it looks like on there. Right, I've been having a look at the Power Hacksaw, see what the vibration is, and I've been looking at the damper, looking to adjust the damper. There's a needle valve here and it controls the rate at which it descends on the cutting stroke. But what I have found is, and I don't know if you can see, I need to try and get some light in there. Well, there's no oil in the pot hardly, so the oil is probably way down there, so it's only damping at the bottom of the stroke. So at the top of the stroke here, on its maximum capacity, there's no damping at all, so it's just falling all the pressures on the blade, on the teeth. So what I'm going to do is get some oil and I'm going to put some in that. I'll just go over the piston. In fact, I'll just lift that up, park that, and I'll set that for the height or the level of the oil. Right, I shall do that now. It's easier to fill just from the oil can. Lift this up and stock it. It's pretty close to the top now. find I put a bit too much in. As it goes down it might come out, but we'll see. We shall see. Yeah, I'm going to put that away. It's definitely got oil in now. I don't think the needle valve here, I don't think it actually sits in the little seat properly. Because it doesn't. I'm going to have a look at this in the future. I'm not quite entirely happy with that. Anyway, let's see what's going on. There we are, we're nearly finished now. It's got it all the way through. Despite the vibration, it's still doing a really good job. It's saved us a lot of work messing about. So yeah, I'm pleased with that. Like I say, I can sort that needle valve out on the damper cylinder. That's not a problem. Yeah, almost there. There we are, that's it all done. Right, we'll turn it round and do the other end. Right, it's working its way through that second end. It's not as noisy as it was before. Put some heavier oil on the slides here. And it seems like when it gets down to a certain depth, it sort of stops a little bit. Anyway, it's doing the job. Right, today I've been messing around with the Power Hacksaw today. I was having a look at this problem with the vibration when it's cutting, especially on big pieces like this. There's two things which are really important. The first thing is this is too big for this size machine. This is probably maximum capacity around about 2 inch by 2 inch. We're pushing this. This bar here is one of the spare, or one of the other ones that we had down by the planer machine, and I'm just using it for a test cut to take the end off here. It's got to be done sometime, so I'll just use it as a test piece. But this, if you look here, I mean that's the part position there. You know, it's virtually touching the material. In fact, it is touching the material. You know, this is too big, this piece here, and if I turn that through 90, so it's lying down, it's too flat. It's too the length or the width of it is too big to go in the vise. So you know, you've got to be realistic with what you've got, the machinery that you've got. You've got to be careful what you're doing. This is too much. I'm pushing it beyond its limits. But what I haven't done as well, I was making some adjustments, trying to control the rate of descent with the little needle valve, and it was doing absolutely nothing. So I started stripping it down, messing around, and you can see there's a tube in there. It's a bit bigger than that one. That's the original one. That's the new one. That's 3/8 of an inch OD, and that's 8mm OD. This is a piece of hydraulic tube. It comes with the kit when you buy the kit from Hemingway, and it's a piece of hydraulic tube, and the size of it is 8mm OD by 5mm ball. So what you do is you've got to thread the ends 8mm, and you've got to thread internally 6mm. That doesn't give you much land inside for strength when you're tightening nuts and things up. And what's happened is I tightened the nut that was here and it snapped it off, and I thought, right, okay, so I need to repair this. So I've made a new rod. I've had to bore the bush out in the top. I've had to drill and tap the piston 3/8 BSF because it was 8mm. I've had to drill and tap this out 3/8 BSF, and then I've put it all back together again. But it's given me the control that we want for descent. I don't know if you can just see it. Can you see it just creeping down now? It wasn't doing that, it was just dropping straight down before. But that's given us the control that we want. See? And the reason why it does nothing at the top here, because you're at the limit to the stroke, you can't put oil right to the top on the dashpot here, because what happens is it just flows out. But yeah, it's just creeping down nice now. What that's supposed to do is supposed to dampen it on the return or the cutting stroke. You find out when it gets lower down, if you do smaller pieces, or if you got a piece like this, it was say 2 inch by 1 inch, and you lie it down flat, it cuts through that no problem at all. You start standing them up like this, you're really on the extremities. It's not good to do that with a machine. With a machine tool, any kind, always try and work within the capacity of the machine. You take it outside and you can have problems. Now, sometimes people modify machines to suit particular applications, but it's, you've got to know what you're doing. But anyway, I've been messing around with this, and I'll just show you it working. I've still got a few little adjustments to make on the switch here to set that distance properly. Oh, I've switched it off. There you go. There we are, it's still going strong. Nearly all the way through now. Alright, it's got the cut all the way through this now, so quite pleased with that. You can see the piece. That was the flame cut blank, or the flame cut bar. That's the end of it. So we took quite a bit off there in one go. But that saves us a lot of messing around with on the shaper or the miller. It'll save our cutters that well. But there you go. Right. Well, that's done anyway. Right, we can get back to our friend the shaper, and we can put the bar in here. We'll support it with that chain. We'll set it up and we'll start machining the ends. And let's get this bar finished, and that's the test piece done then, complete. All right.